Hello, my dear students. Welcome to my YouTube channel. That's Concepts of Chemistry. So today's topic for the lecture is Coulomb's law and the potential energy. But before starting today's lecture, please do subscribe my channel. So today we are going to study the Coulomb's law, and we will apply the Coulomb's law in calculating the potential energy between the two charged particles. In the previous lecture, we have studied about the alpha ray scattering experiment. So very next topic comes out to be the Coulomb's law and potential energy, and by using this technique we will going to find the effective radius of the nucleus, but that will be in the next topic or next lecture. So let's talk about what is a Coulomb's law and the potential energy. So my dear students, what is Coulomb's law? Coulomb's law, it gives the information. Coulomb's law gives the information about the interactive forces, about the interactive forces between two charged particles, between two charged particles. Now let's talk about the interactive forces. These interactive forces, these can be attractive forces or it can be repulsive forces, or it can be repulsive forces. So what does Coulomb's law states? Coulomb's law states that it states that forces of interactions between two charged particles is directly proportional is directly proportional to the product of magnitude of two charges. Let me give you an example. We are having 2 point charges. Let it be a Q1 and that's my Q2. Now they are separated by a distance small r. So the first point states that the interactive forces between the two charges will be directly proportional to the product of magnitude of these two charges. So now let's talk about the another point of Coulomb's law. Coulomb's law, it also states that forces of interactions between two charges are inversely proportional, are inversely proportional to the square of distance separating them. So here what's the distance which is separating them? It is this small r. So the force, that is interactive force, is inversely proportional to the square of distance separating them. So let me combine these two factors, that is this the number 1 and the number 2. Let us combine the number 1 and number 2. My interactive force comes out to be directly proportional to the product of two charges Q1 into Q2 divided by small r square. Now I am removing the proportionality and I am putting my proportionality constant K, Q1 into Q2 divided by small r square. So here what's K? Here K, it is constant of permittivity. It is a constant of permittivity of the medium separating the two charges. So let's talk about the medium first. Let us consider the medium between these two charges is vacuum or air. Then the value of K for air or vacuum comes out to be 9 into 10 raised to the power 9 newtons per meter square per coulomb square. So that's the value of constant of permittivity for vacuum. So now let's talk about potential energy. We will apply the Coulomb's law in the potential energy. Now I'm talking about potential energy between two charges. So I'm writing, it can be defined as the amount of work done. It can be defined as amount of work done in bringing the two charges close to each other. I have given this definition of potential energy only for the two charges. The potential energy between the two charges can be defined as amount of work done in bringing that two charges close to each other. Now let's talk about same. That's my point charge Q1. That's my another point charge Q2. And this is the distance separating these two charges. So now let's talk about potential energy. Potential energy. It is obviously the work done. So what's the formula for work done? It's force into displacement. Now, let us put this formula, the value of force in the formula of potential energy. That's between the two charges. So I'm putting it over here. My force comes out to be K Q1 Q2 divided by R square. And what's the displacement over here? It's again smaller. That's a smaller. It comes out to be. Now, here the square is cancelled. My potential energy comes out to be K Q1 Q2 by small r. That's my potential energy. So now let's talk about different cases of potential energy. So I'm starting with the case number 1. Case number 1. If my Q1 is positive and Q2 is also positive, so potential energy comes out to be is my K, that's my plus Q1, that's my plus Q2 divided by small r. So it comes out to be positive K Q1 Q2 by small r. That's my potential energy. In these cases, now I am considering the signs of charges of Q1 and Q2. So in my first case, I have taken my Q1 to be positive and Q2 also to be positive. So my potential energy comes out to be positive. And whenever potential energy comes out to be positive, that's the case of repulsive forces. Repulsive forces. So my dear students, whenever you will get the positive value of potential energy, so that means there will be repulsive forces between these two charges. Now let's move to the case number 2. Now I'm talking about case number 2. I'm taking my Q1 to be negative and Q2 to be also negative. So my potential energy comes out to be K is my minus Q1 into minus Q2 divided by small r. So potential energy comes out to be minus into minus comes out to be plus K Q1 into Q2 divided by small r. So in the second case also, I have taken my Q1 to be negatively charged, Q2 also to be the negatively charged. Now potential energy comes out to be negative into negative, positive. You got the positive potential energy. That means it will again signify the repulsive forces. So it will again signify repulsive forces. So hopefully my dear students, you got the first two cases of repulsive forces. In these cases, I am repeating again, I am considering the charges, the signs of the charges. Sorry. So in these cases, I am considering the signs of the charges. In the first case, I have taken Q1 positive and Q2 positive. My potential energy comes out to be positive. In the second case, I have taken Q1 negative and Q2 to be negative. My potential energy came out to be positive. When potential energy in these two cases comes out to be positive, that means there will be repulsive forces between the like charges. That means positive and positive charge will repel each other. Negative and negative charge will also repel each other. So now let's talk about the case number 3. Now I am taking some different charges. Let me take the case number 3. Case number 3. I am taking my Q1 to be positive and Q2 to be negative. So I'm taking different charges now. Q1 is positive charge and Q1 is negative charge. Sorry, Q1 is positive charge and Q2 is negative charge. So my potential energy comes out to be K, it comes out to be plus Q1 and minus Q2 divided by small r. My potential energy comes out to be, now plus into minus comes out to be minus. So it's K Q1 into Q2 divided by small r. Now here you can observe that we got the potential energy to be negative. Whenever we get the negative value of potential energy, it signifies attractive forces. So that was my case number 3, when my charges were different. That means the charges were unlike. The Q1 is positive and Q2 is negative. So opposite charges or unlike charges attract each other. Potential energy comes out to be negative for the attractive forces. Now let's talk about the case number 4. Now I'm talking about the case number 4. Let Q1 to be negative now and Q2 to be positive. So it's again unlike charges. I have just reversed the situation. In the case number 3, my Q1 was positive and Q2 was negative. But in case number 4, my Q1 is negative but Q2 is positive. So let me put it over here. I'm writing potential energy comes out to be K into minus Q1 into plus Q2 divided by small r. It comes out to be minus into plus minus. So minus K Q1 into Q2 divided by small r. So here again potential energy comes out to be negative. Here potential energy comes out to be negative. So it also signifies the attractive forces. So that's the very basic rule, that if you got your potential energy value to be positive, it will signify the repulsive forces between the two charges. And if you got your potential energy to be negative, then the negative potential energy will signify the attractive forces between the two charges. So now let me make a graph for you to make it crystal clear. Let us discuss one more case now. Let's talk about the case number 5 now. Case number 5. Take your distance of separation between the charges to be infinite. Now, potential energy comes out to be K into Q1 into Q2 divided by small r. It comes out to be K into Q1 into Q2 upon infinite. Now something divided by infinite comes out to be 0. So potential energy comes out to be 0. It means that if two charges are far apart, I'm writing if two charges are far apart, then there will not be any interactive forces. There will not be any interactive forces. So now let's come to the graph. This is my x-axis, and on my x-axis I'm taking my distance of separation between the two charges. Now This is my y-axis, and on my y-axis I am taking my potential energy. So this is the origin where the potential energy and small r is 0. So let's understand this graph now. If on decreasing the distance between the two charges, potential energy also decreasing. In the first graph, when we are decreasing the internuclear distance, the potential energy is also decreasing and its value is going in even negative. So this graph shows the attractive forces attractive forces between the two charges. Now let's talk about another case. If on decreasing the r the potential energy is increasing. If the potential energy is increasing on decreasing the r, that means the value of potential energy is going in positive. So that means there will be repulsive forces. There will be repulsive forces between the two charges. So that was the topic for today. Now we will apply this topic in the very next lecture in finding the effective radius of nucleus. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear his doubts, then he or she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.